All right, welcome to Christmas Tech with Aussie Phil. It's another evening with me. It is evening time for me. Traffic's going past my garage outside, so if you hear any traffic noise, I do apologise. We're going to look at solar cable, solar DC cable, and just see how good it might be for use with our displays. It comes in 4mm square and 6mm square cable, courtesy of one of the great guys on Oz Christmas Lighting today. Yesterday, I got some 4mm square cable arrive by Express Courier today. So we're going to try it out and just see how good it is. We're going to run some voltage drops tests on it, and we can work out from that just what our current limits are on it and how far we can run it at certain voltages. So let's have a look at the setup. What I've done is I've pulled out one of the 5-volt. And the voltage on this doesn't matter. Remember this. This is about the current down the cable. I'm using 5 volts because it's the supplies that can run up to 60 amps without any issue. And this particular supply can do 100 amps. So we'll make every effort not to short circuit it. And we'll just push that out of the road so we don't have to worry about it. And what we've got is we've got a multimeter there. And we'll show something interesting, or maybe not interesting to most people, but we'll go from there. I want to just sit that one back in there. This multimeter lead is designed, I want to measure the actual voltage drop on the negative side of the cable, just to show that you do get drops on each side of the cable. And of course, what happens is that meter turns off because I've let it sit there so long. So if we just have a quick look at, I'll show you something interesting. We've got, and we'll turn this one on again in a minute. We've got 3 different meters there and they're all showing slightly different values. I have set the supply utilizing the Owen meter to near enough to 5 volts. So it makes all the calculations as easy as possible. And you can see there that my rather old, these days, Digitech meter is reading 507, but the electronic load is definitely reading 5 volts. And when I checked it using this rather cheap, actually, ANEG meter, and we'll throw that across there just to show, it says 5.06 volts. So we're near enough to 5 volts that it doesn't matter, plus or minus a few millivolts. So what we plan to do is we'll ramp the current up on the electronic load, which is what the right-hand meter is showing, and we'll go from there. So let's start with something simple. We'll go with 1 amp just to start with, just to show that it is running. There's 1 amp being drawn, and we have minor little voltage drop. Who cares? So what we'll do is it's actually fractionally easier. I can't run it from there because I'm running it from the computer. So what we'll do is we'll just step up to 2 amps. And of course, things just didn't go my way for a second. 2. Enter. So 2 amps, still no real voltage drop. Let's jump up to 5 amps. So 5 amps of current, we can see that we've got, what's that, 0.170 millivolts of voltage drop on the cable. Again, really doesn't matter. And remember, this is 1 meter of cable. We'll put that in the description. We'll jump to 10 amps. And now we've got 4.86 volts, 4.87 volts. So probably 4.87 is valid. And you can see the electronic load and the Owen meter are starting to come together in terms of voltage readings. And you can see the output of the 600 watt or the 100 amp supply hasn't shifted. It's still showing 5.07. So it has no trouble supplying that. Let's jump up to 15 amps. This is another common voltage that might be used. And we're going to put my talking head there for a minute just to try and assist, and you can see that I'm actually talking. So we'll move the meter over to the side so you can still see it. So 15 amps, we're now seeing 0.3 of a volt drop. This is the sort of voltage drop you might see on a meter of standard 10 amp cable we use around the place. So this is still quite a good acceptable input voltage to your strings. I wouldn't start to be getting too much lower than that. Let's run this up to 20 amps. And if you hear any fan noise, the fans just decide to kick in on the electronic load. Now that we've got some 300 millivolts, 4.7 volts total, let's have a look at what the voltage drop is on the negative side, and it's 1.27 volts. We'll just do this and we'll check it on the positive side, and it's 1.28 volts. You can see there that when you actually have a voltage drop on a length of cable, you get it across the positive and negative leads. So in effect, that is 120 millivolts higher than ground, and we are lower than 5 volts at the top end. This is what Keith dealt with in his article around why do pixels flicker when you have 12 volts, because you're upping the ground and you're lowering the voltage at the top end. So that's sitting there quite happily humming away at 20 amps. Let's jump to 30 and see what we get. Now we're starting to see a bit more drop off. So we're down to 4.58, and still an acceptable input voltage to your strings at 5 volts. They certainly wouldn't be going much past this, but 30 amps from your power supply, we're starting to get pushy on the 350 watt limits anyway. And I'd certainly just be running 2 cables from the power supply to your fuse box. You should always go to your fuses. So from the power supply to the fuses, and then you break it out from there. So again, this would be a great cable. And you've seen what the thing was at 5 volts. We were dropping next to nothing on a meter. We'll extrapolate that out in a spreadsheet for everyone and show what the voltage drop might be later. Now, out of absolute pure interest, and this is the limit of my electronic load, but we're going to drop 60 amps into that across that cable. You can see that my 600 watt supply just hasn't budged in voltage. It's just rock solid. I'm measuring 4.14 on the load, and I'm measuring 4.2, 4.19 on the meter. Let's have a look at what the drop is on the negative side for starters. And you've already seen that this would be duplicated on the other side. So 0.4 of a volt drop along the cable itself. And just for complete transparency, let's have a look at the positive side. You can see me doing that. Can't see me doing it on the other end, but so 0.411. What that also tells me is that the type of wire used on both the positive and negative leads of this are exactly the same. It appears to be, it's quoted as solid copper. It's got a silver coating, so I'm going to assume it's tin coated as well. I haven't checked how well it solders yet. And you can see there as the cable heats up, and this cable is starting to get warm. I wouldn't say hot, but it's certainly warm. The voltage has dropped off a little bit. That's a natural phenomenon. We'll fire up the thermal load and we'll keep talking for a minute. When we finish this, we'll just pull the wires off the electronic load. We'll show you the ends. But there is nothing particularly special about this cable. What I will say about it though is when I first pulled it out and set it up, so we've actually hit around 60 degrees C. This stuff is rated well above that for temperature outside in terms of its coating. So there's going to be absolutely no worries if you do actually get a short on it. What I don't know is, and we'll just turn that off. I'm going to set that back to 1 amp for a second. This load has the ability to go for a short circuit. I'm sort of curious what will happen. We'll set it up for short. It does have an overcurrent limit itself of 61 amps. I expect that the power supply will be easily able to drive that, and the electronic load will go into its own protection. Let's turn it on. And yes, it certainly went into overcurrent protection. So the supply had absolutely no worries driving that. So one thing with this stuff is absolutely put some fuses on it, because if you don't, it's not going to be pretty. You will potentially cause things to go on fire and be nasty and burn stuff out. So let's just pull that off there for a minute. The extra wires on this are so I can get reading on the iron meter. You'll see that drop off. We will get rid of some of the clutter on here, including myself. I'm sure that everybody's tired of seeing me for a minute. So all we did was we have these really good splayed connectors, fork connectors, whatever you want to call them. They are crimped only. These have not been soldered in any way, shape, or form, just to be clear. So they are only crimped. The red and black, they come in the same size. They're available off Amazon. It's really good to be able to polarity code your wires. The cable itself comes with a red stripe, and the inside of it is also red plastic. This still feels warm after that 60 amps going down it, but literally what I do notice with it though is it feels, in comparison to cables, there you go, I shorted that out, made me jump, shorted those two wires out. I probably should unplug the supply. That might be a really good thing. And you can see the supply went, it's outputting no voltage. It itself shut down when it got shorted out. Let me just shut that down. And we didn't really cause any fires or anything. So let's do that again. So 5 volts. We will quite deliberately do that this time. And I'm just going to gently touch them. So this just proves that overcurrent protection does work on the supplies. I'll leave that shorted. It's gone. There was a little spark there. I don't know whether anybody's seen it, but the supply is turned off and it's currently stayed off until I power it down and unplug it. I will actually leave it unplugged just so I don't cause myself any more issues. Back to the conversation. If you're used to standard figure 8, what we call figure 8, so standard, this sort of stuff, let me bring that out there. That's standard Altronics 32020, so 10 amp cable. It feels reasonably flexible. The super flexible speaker cable that you can get is even more flexible. This stuff feels stiff. And there's two reasons it's stiff. It uses a slightly larger diameter inside in terms of the strand diameter by the look of it. I haven't measured it, but it does seem to be a little bit bigger. And the insulation is really quite thick, and it's quite a stiff insulation, obviously out of the solar industry. Conclusion and wrap up though, absolutely. This is suitable. It's not available at ridiculously expensive prices like some of the cables we have to buy and have bought in the past. So I would certainly look at being able to, or sourcing that for yourself. If you really want high power runs between your power supplies and your fuse panels, have a look for the 6 amp, 6mm square. But 2 runs of this would be more than sufficient in just about every case that you might use out there, unless you've got some of those really big 100 amp plus power supplies, like I do there. That would actually make 6mm would be better in that case. And you may be able to, if you go and find your friendly solar installer, you may be able to get hold of some offcuts around the place rather than having to buy a full roll of it. So that's something to really consider. So thank you for watching all that and putting up with me again. And we thank you for watching. Head on over to Oz Christmas Lighting. We will post a thread up with this with some more information around the actual voltage drop estimates across along the lengths, and we can see what happens. Have a good one.